Welcome to the Walton Pie. Today we're going to be talking about limits, which are the backbone of pretty much all of calculus. Limits are one of the fundamental things that we're going to have to understand going forwards in this class. So the motivating idea behind limits is that sometimes we don't care necessarily what the function is equal to at a specific point, but rather we care what it should be if we were to look at the surrounding area. So for example, if we look at the graph of the function f of x equals x squared minus 1 all over x minus 1, it's going to look like this. Now, it's pretty much behaving exactly like the graph of f of x equals x plus 1, but the only place where it doesn't match is at x equals 1. So this is giving us a general idea of what should the limit of the function as x approaches 1 be. So what would the function behave like if it did like what we would expect it if we were looking everywhere except at that one point. So if we're looking at the function everywhere except that point, we can kind of visualize it as if we block off that section and try and extrapolate from the rest of the function what the value of the function should be. That's what the limit is going to be doing. So this is the mathematical version of what that general idea was saying. So if f of x is defined on an open neighborhood of x equals a with the possible exception of a. So going back to this, it's saying that if we are able to find a little region around the point we care about where the function is defined everywhere on that region except maybe at the one point we're looking at. That's what that is saying. So if f of x is defined on an open neighborhood of x equals a with the possible exception of a, meaning we don't necessarily care if the function is actually defined at the point that we care about, then we can write the limit as x approaches a of f of x is equal to L. That is what that statement says. It says the LIM says the limit, then underneath it says as what variable approaches what. So it's as x approaches a, and then what are we taking the limit of? We're taking the limit of f of x. So it's the limit as x approaches a of f of x, and then is equal to some value L. So we can write that if we can make the values of f of x arbitrarily close to L. So we can make the outputs of the function as close to L as we need to, as long as we restrict x to some value sufficiently close to a. So coming back to this picture, we are saying on some open interval, so some region here, we can make the values of the outputs as close to this value here as we want to by just restricting our x's to be really close to the x values of that function. That is what that is going to be saying. Similarly to how we discussed limits, where we're looking on both sides, we can also evaluate a limit from only one side of x equals a. These are what are called one-sided limits, since we're only looking at one side. So for example, this function has different limits from the left and from the right because it's going towards different values. So if we were going from the left, it would be approaching this value below the x-axis, and if we approached from the right, it would be approaching this positive value. If we want to be looking at a left-hand limit, we would write the limit as x approaches a, and then that minus sign in the exponent of a, that says we are approaching from values smaller than a, from the negative side of a. So it's the limit as x approaches a from the left of f of x is equal to L. So we would write that if we can make the values of f of x as close to L as we need to by just restricting x to be some value sufficiently close to a with x already smaller than a. And then we can basically write almost the exact same thing for a right-hand limit, except we are going to have the limit as x approaches a from the right written with a plus sign in the exponent. And then this is going to be true if f of x gets arbitrarily close to L when x is bigger than a and gets close to a. I hope this video helped with the general concept of a limit. In the next couple videos, we're going to go more in depth into limits to define them precisely and figure out how we can compute them. I hope this video was helpful. Please like and subscribe if you would like to be able to see some of my other videos, and please check out some of the videos in the playlist that are showing up on screen. Thank you, and good luck with the rest of your math.